Chapter 2, Section 5, Combining Like terms. So this is very much on the previous page where we did unlike and like. Now, when it's like, can you combine them? You can combine them. So you're going to either add, subtract on this page. If they're unlike, you do not want to combine them. So we're still dealing with Halloween candy. Okay, so I'm going to just write HC at the top again because that is basically what you're doing here. Halloween candy. You can simplify variable expressions by combining terms. You can only combine like terms. Again, expressions do not have equal signs, and if you see in 2a plus 3a, there's no equal sign. Okay? Although there's an equal sign here, but that's just because they're going to put their answers. So, like terms, the variables are the same, a and a. We don't care about the coefficient, which is the number in front. They can be different digits, but you can still go ahead and add and subtract. So 2a, here's 1, 2, and 3a. 1, 2, 3. What do you get in total? There's your 2, there's your 3. You're going to get 5a as your answer. So 2a plus 3a equals 5a. So you dumped out your Halloween candy. You had 2 Snickers and 3 Snickers. And how many Snickers do you have? 5. You can combine like terms by adding the coefficients for number terms. Just add or subtract the numbers. So what they're saying here in example number 1, don't forget that a coefficient that does not exist, you may not see a number in front of a variable, but there is one. And so in this case, this n, how many n's are there? 1. So what's 5 plus 1? 5 plus 1 gives you 6, and then you're just going to attach the n to it. So 5 plus 1n, 5n plus 1n is the same as 6n. Pretty simple on that one. And again, you can combine these because n are the same. And again, we don't care about the coefficient, the number in front of it. They can be different digits. Example number 2, although let me read this right here. Sometimes you need to combine more than 2 terms. Combine them 2 at a time. Combine all like terms in an expression. Now, some of you remember I use the underline, the circle, the square, if I can actually make a square and a circle, and triangles to help me determine which ones are like, and then I can add up my triangles and add up my circles or whatever. Okay? So I'll show you how this works in example number 2. 6x squared plus x squared plus 9x squared. X squared is the same as x squared here, and those x squares are the same as here. The coefficients are different in each, and that's fine. I have 3 underlines, which means I can add up all those because they're like terms. So we're going to start over here, 6x plus x squared, and how many x squared do you have? 1, that's what they've done right here. So 6 plus 1 gives you 7x squared. Notice they keep bringing down what they did not use. Minus 9x squared, minus 9x squared, minus 9x squared. Now, this is where integers, you might have to use your interactive notebook, but let's just pretend we're looking at the numbers. 7 minus 9, some of you may get a little bit confused and be like, oh, that's just 2. Well, remember, this is going to be 7. Keep, change, change. The subtraction goes to addition. And if you hit the subtraction, it's a positive 9. The opposite is going to be negative 9. And when you have different signs, you're going to subtract. So 9 minus 7 gives you 2, and then you attach the sign of the larger number, which in this case is negative 9. So negative goes in front of the 2, and now we're just going to keep x squared. And so this is how they determine that answer. For example, number 2. 7x squared minus 9x squared is negative 2x squared. All right? Moving into the third example, 6x squared plus x squared minus 9x squared is the same as negative 2x squared. Some expressions contain like terms and unlike terms. So now they're going to try to trick you. Terms, like terms, and unlike terms. So when you simplify here, make sure you're only combining the like terms. 2 Snickers plus 3 Snickers. You can't do 2 Snickers plus 3 Milky Ways. It doesn't work. All right, simplifying example number 3, and I'm going to use my underline, triangle, circle method, and square method up here. I'll show you again how that's going to work. So 3x minus 6x minus 2y plus 8y. So I'm going to start with my underline. That looks good. I can combine it with the 6x, but I cannot combine it with minus 2y. So I'm going to make that a square because that's different terms. So I don't want to do squares with underlines. However, I can do the negative 2y plus 8y. So there, I'm going to just do those. Let's do one at a time. 3x minus 6x. And if you did your keep change there, it would be 3 plus a negative 6, which would end up giving you a negative 3, just to kind of make it shorter right here. So this is what they've got there for you, okay? And they just simplified that. Then they did their squares, negative 2y plus 8y. So negative 2y plus 8, those are different signs. I'm going to subtract the 8 minus 2, I'm going to get 6, and then just attach that y. And my final answer is just going to be negative 3x plus 6y because I cannot go any further. Not unless I told you what x and y are. This is going to be a little tricky today. Okay, you're definitely going to need a blank piece of paper, and you're going to want to do your work on that paper to be accurate. So I'm going to do number one on page 39. Show you how we want to do our work. You only have to give me your answers. So again, you're not doing the top 10 box, and you're not doing the bottom two problems going into my blank piece of paper. So if I was on my paper, I'm definitely going to write out our problem. And so number one, I know it doesn't look like a very good number one in parentheses, but it is. 3x to the third power, put my little 3 up here, and then plus 7 x to the third. And I'm going to tell you, go ahead and use my trick. Okay, I'm going to write it big down here. You're going to probably, sorry about that, you're going to probably want to put it on your paper at the top of your page. But my trick with the underline and the circle and then the square and triangles. So if you've got 4 different types in there, then you should be having enough symbols here to utilize to help you. So in 3x to the third, I'm looking at my x and x to the third. They're the same. So I'm going to underline those. This is pretty simple, but at least I know and verify that I can combine those. Now I'm just looking at the coefficients, the number that's in front of the variable. 7 and 3, I'm going to add. That's a 10. And then I'm just going to attach the x to the third power. And again, we've never said go ahead and multiply or add or subtract the exponents. You are simply bringing down what you have. 10x to the third. You had x to the third there and x to the third there. That's just going to stay in your answer. So simplifying this answer, your final answer for right now is going to be 10x to the third. So once you have your paper on or your answer online paper, you just need to submit your answer. Okay, that is all you're doing. The first 6 pretty simple, but be careful 7 through 16. You're going to definitely want to use this little trick that have that has multi different terms. You want to be able to keep track of those. I'll show you. Let's kind of do one really quick. I mean, number 16, you can combine the 2y and the minus 5y, but you cannot combine those with the plus 8. But you can put the plus 8 with the plus 3. So now I know just to combine my squares and combine my underlines, and then whatever my square is, excuse me, whatever my underline is and whatever my square is, that will be my answer for now. Okay, that's your work. 1 through 16. Go.